Let me get that lined up. I've got it here. Okay.
Which includes tea and lunch.
Okay, I'm going to play the video now. I think I'm getting background feedback from someone. I'm muting that Chinese one. I guess part of it was from you too, Flynn. All right, good. Sorry, go ahead.
So we're playing the one from 128 first?
No, the way I understand is we don't really have to play that. Kevin says it's just for their information. He needs what I thought we could provide him the link with the time signature in the link and put that in the chat, and then Kevin can send that out to his people in the distribution end of things.
Okay, I'll get that link here in just a minute.
Perfect, thank you. And then in the meantime, this is the video from the Keshe Foundation site, and I'll put the link in the live stream and also in the chat for people as well.
I don't see the share. Can you try resharing that, Rick, please?
Really?
Maybe it's just me.
It has its little thing around the window like it's supposed to be sharing.
I see it on my screen.
It just could be me. That's working here.
I haven't started it yet. It's just a picture at this point, but just wanted to put it in the chat. Just 1 second.
August the 12th.
There we go. Just give me a minute here. I just wanted to make sure that got the correct thing happening. Okay, there we go. Okay, I'll start the video now. Let's just to remind people, this is called Test Off Grid V212, and it's found in the YouTube. I'll put the YouTube in the live stream, the address up sort of at the top of the screen here, so everyone can get it from YouTube. Okay, I'll start the video.
August the 12th, 2016. This is my MyGrav power generation off-grid set. And as you can see, my wire coming from my capacitor here of this refrigerator leads into the load of the capacitors that go through the MyGrav and come back out into the strip here. And, the ground ties from the strip, ground ties right there, and goes over here to an earth ground right there. Now then they turn the other compressor on. Now we've created a loop, and we can see by my voltage indicator there. We got 121.5. If you've noticed, I've had to put a pair of eye grips on here because this little surge protector is nowhere near capable of the amount of watts that we're going to pull through it. This has a startup capacitance of 700 to 800 watts and a continuous run capacitance of 85 watts. This is a panini sandwich grilled cheese maker, lights on, and it's 800 watts. This, as you can see, is a 1500 watt fan force heater, and we're gonna turn it on all the way up to 1500, and you can see she's blowing, and it's hot. This is a 45 watt hair straightener, and I ran another load over to here so I could turn on a 1500 watt hair dryer. Might want to push that reset button, maybe. There we go. That's the low setting. That's the high. So we got 1500 watts. I'm gonna set it on the ground there. I don't want it sitting on my refrigerator. And of course, the refrigerator is a key part of this. So you can see that it's working in there. Ice in the fridge. Okay, so everything is on and operational. I just stepped on the ground there. And we'll go ahead and turn on these fluorescents too. Forgot about those. And we'll get some thermal readings here for you. Show you that everything's working. Looks like about 345 degrees on that one. Now let's see what the heater's putting out. We gotta clear it. And then we'll go back to this over here. 241. And of course the mag grab coils. The bottom coil is, oh, sorry about that. The bottom coil, try and keep it on there. 116, 111. The middle coil, 96, 95. Oh, and of course the top coil looks like bouncing back and forth. We're going to say 115. We got right here 87 degrees in that. Right there. Wires 88, 91 degrees. The hair dryer is still running. The heater's still putting out plenty of heat. We'll come over here. See what the hair dryer is putting out. Hot enough for me. 171 degrees there. So everything seems to be fully functional in operation. Like I said, we use the capacitor startup run cap, and it starts the system. And this makes an infinity loop plugged into the system. That creates the voltage. And if we add up the wattage here, we got 15 and 15 is 3,000, so that's 3 kilowatts. 8, 3,800, 54 to 3854. And let's just call it even 100 on the 2 refrigerators. So 39, 54, and 50 on that. So 40, 4K right now. It looks like what we're pulling off this particular unit. You can see I had a piece of matter copper there. It got hot. None of this did though. Look at that, huh? 116 degrees, 104, sorry. And we'll get over here on this now that it's nano. Look, 200 degrees. But you go right here, and you see it starts dropping down. And that's a little bitty 20 gauge stranded wire. But it cools down as it goes through the mag grab. You can see it's dropped down to 94 degrees. And now that this is nano coated, the next time I fire it up, it will be at a lower temperature. It won't get that high. Like the rest of these, you know, they don't get high, 88 degrees. They've already been nano coated. Once the nano coating process takes over, then it's all it does its own thing from there. Well, anyway, that's more than 4 minutes to show arming, and I'm hot enough out here, and I've got heaters blowing, and hair dryers are going, and everything. We'll leave the lights running and get the. Let's see, the two compressors are what runs everything. Everything can be taken off of here. You don't have to, as you can see, I've got an earth ground. You don't have to have an electrical source. There's no wires attached anywhere around here at all. You know, so anybody can see it comes off the compressor right there. There's no wires except for what's on the ground. That goes to the hair dryer, back down to the strip. Like I said, if it wasn't for those vice grips, we would have never been able to do that, because that little surge protector will only allow so many watts to go through it, and we just pulled 4,000 watts through it, so they're not rated at that. A 14 gauge wire is rated at 1440. And as you can see, this wire is not even hot, and it's a 18 gauge stranded wire. And look at this little bitty wire here. It's a 20 gauge stranded wire, and it didn't melt at all. You know, piece of matter copper got hot there, but that was something I threw on at the end because I burned a cap earlier. But even with 3 caps, we still managed to pull 4Ks. So, and we showed the thermal indication that all the units were working. And as you can see again out here, there's no wires, just an earth ground. I do require a ground. The appliances have their own ground, but they're not earth grounded unless you're hooked into the grid. If you're hooked into the grid, then you've got a ground for your appliances through your neutral. But when you're off grid, you don't have that ground for your appliances. And in order to make these appliances with the start run capacitors to operate properly, you need a ground. So this is the earth ground, and you know, I chose to use a number 8 solid gauge solid copper wires. So so this is I hope will satisfy everyone's curiosity and show that the marvelous feat that this unit is available to do. You know, it will perform a specific function, several actually, but one of the main functions is not only the power generation ability, but the ability to carry massive amounts of current and wattage through nano coated wires, and through the nano coating process allows this to become a superconductor, which allows the electricity to travel through here at a higher rate of speed, frequency, if you will. So you know, less resistance. If there's no resistance, there's no heat. You know, this is a new piece of wire right here, you know, and it's warm to the touch, but it's not hot anymore. But that's the reason it, you know, became hot, because it was a brand new piece of wire. It hasn't been nano coated yet. So this was, you know, put in here on purpose to show you. You see that none of the rest of that left a mark there. You know, just the one spot right there. I had my knee on that ground, and like I said, the two systems are making electricity right now, so it will give you a little bit of a shock there if you touch the ground on one side. But anyway, I hope this satisfies everybody's curiosity, and peace and blessings to all. And thank you for this wonderful opportunity.
Thanks, Rick. You there?
Yes, indeed.
Okay. I zoomed you over the other link for the one from last week.
Let me have a look.
Can I ask a question? Hello?
Hey, Tubiorn, how you doing?
Hello, hello.
long time no hear.
Yes, horrible.
What do you got?
Yeah, my question here is that it looks like Douglas have liquid plasma in the GANs coin.
In the what?
In the GANs, or instead of the GANs, it's liquid plasma?
I believe it's both.
Yeah.
I'm not sure.
But can you look through? It looks like we can look through his...
Yeah, you have to rewind the video there a little bit, Rick, for a clear shot.
You mean right there? You're talking about the ball of GANs?
Yes. They don't look like ping pong balls.
No, I think he's using his smaller acrylic balls that he's gotten to use the triple core stuff to get the right diameter. Because ping pong balls are actually just a wee bit big, right?
Another question is when he's talking about the capacitor in the fridge, that's a capacitor from the very fabric for the unit.
Could you say that question again?
I'm sorry, Rick. When he's talking about the capacitor in the fridge,
Mm-hmm.
is that his own capacitor, or is it the capacitor from the fabric?
What do you mean fabric?
Oh, the label, just
Yes.
using the...
Yes, it's the capacitor in the fridge, is what I think he's referring to, correct?
Yeah, that's what I understand, yeah.
Because usually those, they look like... well, I had a look at my fridge, and it looks like between the in the connections, it's like a small bottle made of copper. Is that a capacitor from the fridge?
A bottle made out of copper?
Yes.
It doesn't sound like a capacitor. Usually it's not copper on the outside. It'll be like look like a little canister on some motors. I'm not sure what this fridge will have on it, but a small black
The
painted
bottom
can.
with the capacitor is most likely the container for the freon gas. So I think that's what you're looking at.
Yeah,
Exactly.
that's right.
Exactly. But is it easy to find the capacitor from the fridge?
Well, it'll be attached to the motor circuit, close to the motor or attached to the motor in some cases. I've seen.
Does it look like our capacitors?
It looks like anything from a D cell battery to a D cell battery that's 5 times as big, say.
Okay, thank you, Rick.
And if you go to a refrigeration parts place, they'll have a long aisle of capacitors for compressors and boxes of them, because there's each capacitor is specific to certain size motors to start them. And somehow the capacitor is used to essentially jumpstart the maggrav generator system, is the way I understand it. It's the heartbeat, the pulse of the system.
From the fridge?
The fridges are the two most important parts of the circuit, apparently. That provides the pulse.
But on the maggrav unit, it seems that Douglas only had 3 capacitors.
Mm-hmm. Yeah, one blue.
Yeah, he said he was doing some other tests with it in the video there, and that it blew. So he's, yeah, because the one he showed last week actually had 4, and these are his special design capacitors too.
Yeah, and then he hot wired it basically with that little blob you see. If you see my marker there, there's a little, well, as Douglas was pointing out in the video, when he was taking the temperature on it. Let's just go back and have a look at that detail. Where was it? Just that part right there.
None of this did though. Look at that, huh? 116 degrees, 104, sorry.
Okay, so it was 104 degrees where the third capacitors lined up here, where the fourth one would have connected. It was like 130 degrees or whatever, not that hot. And then he continues.
We'll get over here on this now that it's nano. Look, 200 degrees.
So it's 200 and some odd degrees for this blob part that he's added, this little coil that he's added on, that he said was not nano coated when he added it. So because it was the matter level material, it started over. It's the only part of the circuit that was overheating, and it still runs hot. But as it nano coats, it's getting better and better apparently.
But you go right here, and you see it starts dropping down, and that's a little.
You can see that piece of wiring there at the top of the picture, and that's the part that was getting hot, and it actually burned and embedded into the wood of the board. But the wires going in and out of that piece of new wire that was added are good in terms of the temperature, which is quite remarkable actually. Because the wiring, like you can see there, some of that really thin wire, I believe it's 18 gauge, it just shouldn't be able to handle the kinds of loads that are being put on it there.
Bitty 20 gauge stranded wire.
20 gauge.
But it cools down as it goes through the maggrav. You can see it's dropped down to 94 degrees. And now that this is nano coated, the next time I fire it up, it will be at a lower temperature. It won't get that high.
But
Yeah.
Rick,
Mm-hmm.
What is really interesting for people to know is that when I made the testing of the double maggrav unit that I made recently, I had over 5,000 watt on it without any nano coating connections. And I realized that during the process, in the beginning, as I started all the ovens, each and every one of them was 1,500 watt each. And so I just kept on putting on the load side more and more and more ovens. And I surpassed 5,000 watt. I think I approached 6,000 watt. And I realized that in the beginning, only in the beginning, the connections got, the wires got hot. not really far from melting, and then they actually started to cool down.
Right. Once they nano-coated, you mean, then it starts to cool down?
I don't know. I didn't check in the connections, but they started to cool down after 6-7 minutes. You know, it wasn't for a long time. It's just in the beginning, and then it cools down.
Mm-hmm. Okay.
And coming from the Maghreb unit, it's not hot at all. It's just the elements responding.
Mm-hmm. Mm-hmm. Interesting.
It really is. And I guess it's all about electromagnetic energy rather than electricity.
Yeah, I'm not even sure if we can call it electromagnetic. I think it might be off the spectrum of the electromagnetic spectrum, but
I know it's not. It's a 7-hour discussion. The difference, because you see, if we go back to the presentation in Rome, when Mr. Kirsch was testing an American system, this was a European system, 110 and 220. And on the load side, both of them are working from the Maghreb unit.
Yes, right.
And that can only be explained because it's. I doubt that the Maghreb unit is providing as a relay 210 for one and 220 for another. I just think it's that's the difference between natural electricity, where I'm actually calling it electromagnetic energy rather than electricity. It's like in the brain, you know, when we measure the electricity during brain activities, it's milliwatt, and I think milliwatt is a misunderstanding. I think milliwatt is the translation from electricity to electromagnetic energy.
Mm-hmm. Okay.
Could be electrogravitational energy too.
Yeah. What about that? Maybe it's magnetical gravitational energy.
That's why they're called magravs? Really?
Ah, what a revelation! But how do we measure
Another
them?
question for you guys is how many do you think of these elements are nano-coated straight into the element itself? All of them?
Say again. What do you mean?
If the connection through the element itself and the wire to the load side, are they all nano-coated, you think?
The wiring on the load side in the Maghreb unit, you're saying?
No. I guess from the Maghreb unit to the load, it's all nano-coated. But from the elements, like the air pump and all the elements, are they nano-coated straight into the unit itself? All the wires?
I think over time it would be. That's my opinion.
Yeah.
Yeah, it makes sense.
So that explains why you said it's working better and better.
Just like you said, that red wire in the picture there, if you peel back the coating, the entire inside would be nano-coated, where it was not before.
But another thing to think about is nano-coating, an actual nano-coating, we can't see the initial nano-coating. So a wire could be nano-coated and it wouldn't necessarily be black. It could still look like copper and have a few atomic layers of nano-coating on it enough to do the job to transfer the plasma.
But you got to remember,
Exactly.
the plasma is transferred already, so it's already creating that initial nanocoating. It's like structuring it as soon as you hook it up.
Mm-hmm.
We just have to remember what the Germans, when they used a battery to nanocoat a wire, they actually turned off the process when the copper starts, when it was clearly darker, but it was far from black. And the rest of the procedure, they knew that if they took off, using negative and positive just to force the field with heat, and they nanocoated it and stopping when it got reddish, and then they just took off the battery. So a couple of 3-4 minutes later, it actually turned black.
Yeah, the disadvantage I could see possibly with that process is, for example, that's typically what happens with an extension cord. If you use, say, an 18 gauge extension cord or 20 gauge extension cord, and you overload it with too many appliances, then what'll happen is it'll turn that cord black inside. It oxidizes the copper in a similar process as what we use in the Keshe Foundation, but the difference is you might as well throw away that extension cord after that, because it'll always overheat and it will tend to burn out in certain sections. And the reason it'll burn out is that kind of process, by overheating the entire wire with electricity, meaning the inside part of the wire is also overheating. What happens is it crystallizes the whole wire, and so it becomes
Disaster.
pardon me?
A disaster.
Well, yeah, it becomes
I remember in the beginning.
Because it's chaotic. It's not structured. It's chaotic.
Exactly.
It's chaotic, and what's happening is the whole structure of the wire, all of the wire ends up being what would you say? It's oxidized, but it's not necessarily in the structure that we wish. Like normally when we do a caustic or even the heating process, it's on the exterior part of the wire, and that's where the plasma tends to flow. It doesn't flow inside the wire, it's flowing.
Well, we can explain this with Mr. Keshe's terminology, and that is, if we have the SP2, it flows readily. If we have the SP3, it blocks it, right? It creates more resistance. Is that correct? Or is it the other way around? I can't remember. So if you're creating a chaotic structure, what you're doing is creating basically SP2, SP3 all together chaotically randomized instead of a structured SP2, right?
Yeah, basically I'd say.
To try to explain it.
Structure on the outer surface of the wire. We're not using the inside part of the wire, just the surface of it normally. And that allows the inside part to do its normal thing, perhaps, with whatever it does with the electricity, without having to worry about overloading it and that kind of thing. But definitely it doesn't work with extension cords to turn it all black and have it work better in a normal situation with the normal electricity, at least. Maybe that's the best way for extension cords with the MagRav system. They all need to be basically burnt and fried first, and plug them in. They work great. I don't know. I'm not recommending that, but some science done there.
Rick, I think there is another serious thing to consider during the presentation of Douglas here, about, because he's mentioning it very fast, but for us who is going to really take this seriously and very fast, he's saying that he creates a circuit when using the elements. So it's like a circle around, or where the MagRav unit is part of the circle, and this is going to be the infrastructure in the house. So you have to change the infrastructure, starting with the from the capacitor to the MagRav unit, and from the MagRav unit to the fridge.
Yes, it seems like they have to work with each other and so on. Now, it's interesting. I've heard predictions there's predictions from the major manufacturers that refrigerators will be self-powered within 5 years, and other appliances as well. So in a way, this is the way things are going. It'll be some sort of symbiosis with the appliances of the household, and probably they'll be sort of talking with each other or communicating in a way that they work with each other in a cooperative, plasmatic way. Like somehow Douglas mentioned the 2 fridges were important as part of this circuit. And before you said that, I sort of had an idea that the fridges were important. It's been mentioned before and so on. But I hadn't thought of them in terms of an integral part of actually jump-starting the circuit through their capacitors and so on, which store electricity when they're off. And that somehow this interacts with the MagRav system and so on, and they all get on together, and you know, it's a happy family of appliances apparently.
It's about algebra, Rick. How good is your algebra?
Or is it geometry? I'm not sure. I mean, we have a partly dysfunctional family here. We had one capacitor that decided to leave the family, but yet it continues functioning. That's the funny thing about it. It seems like it's almost like none of the parts are mission critical, but yet they all have to work cooperatively together to get the job done and do their individual things. It's mind-blowing to me from trying to approach it like looking at things from a electrician's point of view, for example. I tried to look at this technology from different viewpoints or different windows, as Mr. Kesh says. If you look at it from the electrician's window or viewpoint, this would be outrageous. You wouldn't normally be using, normally if you see a wire that's black, that's copper, and you're an electrician, well, you rip it out. That's what you get paid to do, is replace wires like that with shiny, nice copper ones, because that indicates the wire's overheated and is no longer any good. It can't handle any current, and it is no longer useful in a house, and indicates that it already almost has caused a fire or will cause a fire in the interior walls of a normal household. But in this case, you want the wires black. If they aren't black, then there's something wrong. It'll tend to overheat and cause trouble. And so everything's backwards. Even the plasma flows backwards to the flow of the electricity. And so if you try to approach this from the window or viewpoint of the ordinary electrician with all of his years of knowledge and experience, you would tear your hair out and probably run screaming in the other direction. But on the other hand, if you were to look at this whole situation from a refrigeration and air conditioning person's, technician's point of view, which is different than an electrician, but sort of includes that as well, then again, it just doesn't make sense. You shouldn't be able to use a refrigerator to jumpstart a generator. This is totally counterintuitive and backwards. Once again, totally backwards. The other way around. Jumpstart a generator to get your refrigerator going.
You know, Rick, Mr. Cash is going even further, saying that if Douglas were to throw the whole the whole magrav unit with the capacitors in the sea, we will be amazed. Throw the whole thing in the water.
Yeah, right.
Yeah, that's right.
I mean, you know, I would scoff at that in years past, you know, and say, oh, yeah, well, it'll just corrode and drop to the bottom. But now I'm not so sure. I don't know what would happen. And, you know, it's a whole new ball game where we can't just make assumptions that we did in the past.
Well, if you look at it there, if you zoom out or move the video to where it was zoomed out, where you can see both the compressor and refrigerator on either side of the magrav. Somewhere in there. Keep going, yeah.
Maybe
it was like he was at the back side of the thing there, and he had the refrigerator on the right and the compressor on the left. There you go. If these two are needed, you can do a figure 8 with the infinity loop, and the magrav is in the center where the free plasma is generated.
Well, that's a good point. That's a really good point, Flint. Let me see if I can get that a little better here. There.
And so it's these two things that create an infinity loop. And if you remember, I couldn't even begin to tell you which one it is, but several knowledge seeker workshops ago, Mr. Kesh was holding in his hand what he called the butterfly circuit. And it was two of these flat coils tied together in a butterfly situation in the infinity loop.
The fridge is creating isotopes.
So it's the circuitry in these things that need to be replicated into your butterfly coils, nano-coated butterfly coils, positioned in the same way. Because you take this coil here, the top coil. I know you can't see my mouse, but you take the top coil and put it on the right side, and the second coil on the right. Not that you do that, but you have extra stuff that you make, and you create the butterfly coil infinity loop to replicate the circuit needed to jumpstart so you don't have to have fridges.
So, what would be on the wing to replace the compressors now? You're saying it would be capacitors, or what would be there again? Another magrav?
Your double coils. The two coils that are on the top plate there. You have a double coil system on the left, a double coil on the right, and the two are tied together somehow.
Mm-hmm.
Yeah, I don't know.
You're far out, Rick. This is not the butterfly effect.
Okay.
I'm about to try. I made the unit, and I was thinking to test this new Douglas's concept in a couple of hours. I'm going to film the event.
Well, that'd be great if we had a couple of breakthroughs during our broadcast here, where experimenters were actually popping up that could duplicate this technology. And Mr. Kesh has mentioned releasing the blueprint today, actually. So maybe we will have some breakthroughs before the end of the day. That's how fast this can move in this point in time in our history as humans. We have the technology of communication at the same time as the ability to duplicate things and create things quite easily. So this is, it's kind of a unique time that people can watch at the same time as recreate their own MagRav units into a generator from a grid system, and possibly make them self-sufficient, maybe even before Douglas makes it to Washington to show them the first MagRav that's ever been developed. Maybe there'll be hundreds following in literally in his footsteps, because of the release is so immediate now of the technology. In years past, someone that had some invention that would get out to the rest of the world for years and years, if ever, in some cases. We are indeed we're fortunate to live in these times.
You know, yesterday I had a 5 hours presentation for the Polish people on plasma technology, and I realized when it was finished, Carolina had distributed this film with Douglas, so I was 1 hour too late. But then I realized, so of course I can't speak for the whole world, but here in Norway, people are their impression looking at Douglas's presentation, they're absolutely just their head becomes just a sign of a question mark, and perplexed. You know, they don't know what to think of this. And I hope that the blueprint is going to be a bit clearer than Douglas's presentation, of course. But even if we can see how this is working, and this is a great victory for plasma technology and Keshe Foundation. But I've realized that so far, the reason why people are looking at this and actually they don't understand the buckle, It's very, very strange reaction.
Yeah, I thought it was a strange reaction until the first couple of times, and then it'll be natural to have a device that's self-powered, and in a year or two we'll be going, well, why didn't we have this years ago? This is a no-brainer. Why did we have all these batteries all over the place, and all the landfills and all these issues and poisoning of the mercury and everything else from our systems, and all these different transmission systems for electricity, and so on and on and on.
But Rick, we have 5 kids, and I remember last year when I made my first MagRav unit, and I told my kids that this is free energy, and their only reaction was, "Oh, that's good, Father, that's good." And then they changed the subject, and I was like, no, this can't be happening,
Well, that's right. To the kids today, it's no big deal. Like, for example, a lot of the younger folk today, they're not interested in driving the way that people were in the past, because there's other means, and they don't have that same urgency for some reason. And to them, moving to a different type of system with some sort of flying system with or positive positioning system and that kind of thing, it'll be a no-brainer for them. And of course, we won't be flying them with joysticks and so on. It'll be an automated system that'll be controlled so that there'll be no accidents and that kind of stuff. So they'll move right into that and continue playing their Pogoman games as they walk into the spaceship and zip off to Europe or the other side of the world for lunch with their friends and playing Pokemon the whole way. And when they get there, and it'll be nothing to it. It's just why not? Why not have full freedom, full ability to move, be with your friends anywhere in the universe that you wish to be, and have fun while you're doing it without having to pay attention to the technology of it. We're all into this movement of the technology and so on because we can see where that's going and we like these changes and so on. But why do we want these changes? It's ultimately so that we can feel more free, feel more secure, and make it so we're able to be with their friends and play Pokemon on the other side of the planet or other side of the universe if we want, and go and show other people how to do it and have fun and interact and that kind of thing. But yeah, the kids today, they have a different attitude, and maybe it's a more advanced one in a way. Less identified and concerned with the technology. Technology is just there to get you from point A to point B, and don't worry whether it's a red car, black car, blue car, or a sports car, or SUV, or whatever, and go with whatever the flow is at the time. That's the most efficient way for you to get from point A to point B to be with your friends, or be with your friends in a comfortable way on the way from point A to point B. But the point about it is that you're with others or going to be with others, and to part of this interaction and mixing of peoples and cultures and civilizations and so on. That's we're doing now on the planet and off planet as well, as we understand it.
Rick, I was thinking of something that we we should have a discussion on, because I don't really get the whole idea from, when we all started in, I guess it's about a month ago, we're starting to use the fridge on the load, and a friend of mine, we have a new warming pumps. I don't know what they're called in English. Warming pumps. It's like
a warming pump. Pardon me.
Yeah,
it's like a heating system.
It's a heating system, but from their.
It's called a heat pump. Yes, heat pump.
Heat pump. Yeah.
Yeah.
But when you compare, because what I thought was that the fridge with all its relays has a connection to the drying machine and so on, that it's all the different usage, like for example when the unit goes on and off by itself using different relays, that makes it quite complicated to calculate why the Magrav unit is responding better to it. But then I went a bit further, thinking what does all these elements have as common things, and I found out that when you disregard the relays and you pay more attention to the fact that it's actually transforming molecules, that's the whole principle of heat pumps, and that's what they have in common with the fridge. So when you're transforming molecules from a later product that we would easily call the difference between cold and hot, and you realize in order to do this, you have to transform the air molecules, and I think that's what the Magrav is catching, exactly that procedure.
Rick, can I ask a question?
Yes, sure. Who's speaking?
This is Steve from California.
Good, thanks.
Looking at the infinity loop that's in front of us, it would be interesting to, at some point, open up the compressor like on the left and see if the coilings in there have nano-coated. Because I think, as you were saying, the wire being black or not black isn't a true representation of whether it's been plasma coated. Does that seem fair to say?
Right. So how, if you open it up, how would you tell?
Right. So because just looking at where the bare copper wire was attached to the maggrav that had been caustic nano coated, there's not a real, you can't, it doesn't actually turn black over time, does it?
Well, that was my point. It may not turn black necessarily, but still could have a nano coating on it. Like, for example, plastic containers can have a nano coating and still look pretty much the same as they did before. They might look a little more dull or something like that. But the difference would be if you use a electric meter and take a resistance check on the surface, it would show that would have infinite resistance, basically, or close to it, very, very high resistance from the nano coating. And even though it may not be visible, it could be easily measurable by an electrical instrument or some other way. You could use an electron microscope or something like that, I suppose, but most people don't have them in their back pocket like a meter.
Right. That's like what I had when I was trying to nano coat aluminum, how to tell if it was a true nano coating, and by using your multimeter on the resistance scale, and if you put the probes on the sheet of aluminum and you had infinite resistance, well, that was opposite to what you'd normally see if you put your probes on aluminum, where you'd have continuity. Is that correct?
Yes, but I think that not all nano layers are the same. Not all materials necessarily would make an insulating nano layer like that. I know copper tends to do that, and graphene, I believe, is a similar way, where it tends to conduct electricity one way but not the other way as much. But zinc can be different. Zinc oxide, for example, can be a piezoelectric material in itself. So just the act of bending it can produce electricity and so on. It's and again, the structure itself of the nano layers. There's so many different ways and means of making these structures. You could have a copper oxide that looks like just a bunch of flaky, fluffy stuff when it's magnified. You could have copper oxide that looks like very structured, perfect little pyramids. Or you could have rods that are sticking up like a forest or a bunch of hairs and so on.
Right.
All these different configurations have different properties. But the ones that we're often using with the Kesh technology, the one where the standard caustic coating, as we call it, is generally one with multiple layers and high resistance through the layers, but essentially superconducting along the length of the layers. So it's yeah. Anyway.
So getting back to the to looking at what was created, perhaps what occurred was that both compressors being exposed to the maggrav over time nano coated and created the cascade effect like we were trying to do with back before, with just having one mag grav, on-grid mag grav, and then we added a second on-grid mag grav, and that created the cascading effect. Maybe at this point, with the off-grid, you have two units that are cascading with that center mag grav to create the infinity loop. Maybe that's why the positioning is so important on the table. And I don't know if he can.
Well, I would. Okay, that's an interesting theory. I would venture that I don't believe the wires need to be conditioned, or the appliances. It was said something about the appliances don't need to be conditioned before being plugged into the system and so on. I wonder if that's true. The fridges here as well, the compressors.
Yeah, they could be, because in the video last week, he had the refrige on one side and the compressor on the other. Now that could have been just because of the table.
But I think it's because of, not because of the nano coating that's important. I believe you could use essentially any refrigerator and substitute it for that one, say the one on the right there.
Correct.
You could plug it in and plug in the wires, and you wouldn't have to wait for it to be nano coated to work. No. I think the fridges just provide the pulse that is the core of getting the system jump started, which was provided by plugging into the grid before. We didn't have to have the grid necessarily nano coated for the MagGrav device. You know, a lot of them would start working right away. You wouldn't have to wait for months for it to work necessarily and nano coat the whole house and grid. And
so it's the pulse or the field that it puts out that activates the plasma vortex.
Right. Now, whether the geometric location of the units, seems coincidental that the MagGrav unit is pretty much exactly right in between the two compressor units here. And, you know, maybe there's something about that. Maybe there's certain fields being given off by these compressors due to their pulsing. You know, you hear a compressor run, and when a fridge kicks in, you hear that sort of little pulsating taking place.
I think it's the fields. Yeah, I think there's something to that. That's all I'm saying.
Right. So is it the fields that are given off by these compressors, or is it tied into the actual electrical wire that comes out of the units that are plugged into the electrical wiring where the pulse comes from?
I wouldn't necessarily say it's the compressors. It's the field that all the wires and everything working together generates. Because don't refriges create both AC and DC? Isn't there both in there?
Well, all AC is usually converted to DC to make anything work these days.
Oh, okay.
There's a transformer that would be there. But also, if you look at it, if you think about it, the compressor on the right has inert gas in it, where the one on the left has atmospheric, because it's not a sealed compressor anymore, correct?
Mm-hmm. Yeah, that's a good observation.
So the difference, perhaps, you know, where one's giving and one's taking may be a part of it too. One has an inert gas and the other one has atmosphere in it, perhaps.
Yeah, I tend to not go there with the gases being involved, but it's a nice theory. It goes right along with the Keshe teaching, and we can certainly insert it. But I think it's trying to drive a square peg into a round hole with a large sledgehammer. It'll work.
But it's something, if we know we can disregard it then if it's not part of the process then, so we don't have to make that argument in the future. Oh, it's, you know, the difference in.
Yeah, I've never heard anything about the gases involved being brought up, but it's certainly a good idea. Why not put plasmatic vapor in these units and have them work differently or something? But I think that we should try to focus more on, you see this tiny little wire that comes out of the MagGrav's unit and goes back to the refrigerator and ties into the refrigerator. Well, that's the critical point, I think. It doesn't tie into any of the gases or anything. It ties into the capacitor. At least we're told that it's right directly into that capacitor circuit. It bypasses the wiring and everything else and just goes directly to the capacitor is the idea. And but the other compressor, we don't see a wire going directly to the capacitor that we can tell. It seems to be wires that it maybe that's what's going on, but it seems to be more wires that are going to the two wires that would be part of the motor in the compressor. Obviously the compressor on the left is running, and it would require those two wires to normally run on its electrical power. So, and there's no third wire going to it like from the other fridge. So either that one thin wire going to the big fridge on the right seems to be critical to make the MagRav unit have its pulse circuit, I would say.
And is that on the gravitational side, the inbound side of the MagRav?
Well, that's the way I understand it. If someone else has other information on that, speak up, please. But
because as I was saying, in conventional electrical theory, there's no completed loop there. Even though there's a ground added, there's nothing on the gravitational side that's not tied into the ground, or the neutral or the common, how perhaps we normally think about it, correct?
Well, it is part of a circuit in that it's got an in and an out to the MagRav unit through the wires there. The pulse going in from the fridge and the other wire coming out to the main hot wire that's rigged into the lights. And I think it ties into right into the middle light there, one of the light circuits. So it does have a draw on one side and then the pulse on the other. But it doesn't look, it's not normal. No, it doesn't have a completed circuit where you'd have the hot wire coming in here and so on. Go ahead, sorry.
So then, no, just thinking about the three capacitors there's no actual physical connection. If you take the capacitor apart, there's no actual, because the paper separates the inner stylus from the outer coiling.
Hopefully, yes. That might have been the problem with capacitor number 4. Rest in peace. Rest in peace.
That it arced and something got on it and perhaps it just wore out.
Yeah, that kind of thing happens with the capacitors before they break in properly, and you try to fire something up too early and you have them too wet, the paste is too wet or something, then the water and caustic and so on, it can cross over the circuit and cause short circuits basically.
And these are just the isolating capacitors that we built in the beginning, not the plasma capacitors, correct?
I don't know about that. I assume there's some sort of plasma.
Well, I don't really see any feedback, feedback loops from the outer coil. It's not looping back, so I don't see that. That's why it just looks like a stylus, some paper, the aluminum foil, and then an outer coil.
Well, hopefully we'll get some more information on that later today with the release of the blueprint teachings.
Okay, that'd be great. Okay, thank you.
I think a while back in one of the workshops, again, I couldn't tell you which, he's not, those are his special caps, and he's using a long aluminum tube instead of foil. Much more robust.
Do you know if it's been nano-coated?
No, I don't. I'm sure. Okay. Well,
I'm sure probably everything's nano-coated in that loop.
Yeah. We'll have to.
I can actually show the unit that I made from last night. It's
okay, sure.
Yeah.
Where, are you doing everything for me, Rick? Am I supposed to do anything? Share screen?
Go ahead. You should be able to do it now.
Is something happening? Oh, it's
You have to make sure you have your thing open first and don't show your whole desktop if possible. Now we see you.
hello.
Hi.
Why don't you spotlight him so you don't switch here?
Yeah.
This is the unit.